Just check your notation. Does everyone know what capital X means?
That's like the discrete random variable.
Yep. Does everyone know what this means?
X is a discrete random.
Yep, so this is the probability of success. N is the number of trials. So it's saying what's the binomial distribution of the discrete random variable over this many number of trials with this probability of success. That's what that notation is. Okay, so if Ethan has to answer 3 multiple choice questions and each question has 4 options and he's just having a guess, he's not actually, I don't know, doesn't know what he's talking about, determine the binomial probability distribution. What is N? How many trials are there? There's 3 questions, 3 trials. Each question, what's the chance of success? What's P?
Theoretically 1 over 4, but it's not specifically stated, but we assume there's only 1 correct answer.
Yeah, there's only 1 correct answer. What's the probability of failure? 3 out of 4. So each question, 1 of them's right, 3 of them's wrong. Okay? So hopefully you've seen this before. Does this look familiar? And there's this thing NCR, which is a combination equation. And you multiply that combination equation by the probability of a success to the power of R. Oh, this should be, I knew it was for my pen. Times Q to the power of 1. So this says the probability, the random variable, is equal to R. So we used to use little x, now we're using little r, where, you know, r could be 0 correct answers, r could be 1 correct answer, r could be 2 correct answers, or r could be 3 correct answers, because there's only 3 questions. So r is going to go up to 3. Okay, and you can use this to find the probability of each random variable. So the random variable being 0, etc., all the way up to 3. Not understand this bit. Like, has anyone read, had a look at that? This is like a combination equation. And it looks like this. So that's what it's equal to. So this is where you're subbing in the final. So 3 correct, 3 minus, I don't know, say you're going for 1 times 1. You guys, have you seen factorial before? I don't know if a long time ago. So factorial looks like this, 3 times 2 all the way down to 1, starting at that number.
We did that.
Yeah, so you pretty much just sub in, you always sub in n is equal to, for this question, n is equal to 3, and you just start with r equals 0, sub that in, you'll get the probability when r equals 0, we know the success is 1/4, and you multiply that by 3/4 to the power of n, which is 3 minus 0. So that's r equals 0, and you go all the way to r equals 3. And that's your probability distribution. It's all the different probabilities. Let's have a look. Menu, probability, I think. Yep. Combinations. and then you type in the N and the R. Like that. Of 0 equal to 1. So this is the bit you need to type. This is the bit you need to type into your calculator. I thought that would happen. So the probability of getting 0 out of 3 is actually quite high. If you So stats, distribution, let's try A. Ah, nice. There you go. So that's the quick way of figuring out. So if you guess approximately 42% chance you'll get all of them wrong, approximately 42% chance you get 1 out of the 3 right, approximately 14% you'll get 2 right, and approximately 1.5, 1.6 that you'll get all of them right. So you can see in these guessing quizzes or guessing format of multiple choice, it's usually very unlikely you're going to get all of them right. The other thing that hopefully you've had a look at is the variance. Did anyone get a chance to look at this? And the standard deviation, or SD.
Or also EX times PT. 150, sorry, 150.
The variance is equal to the number of trials times the success times the failure, which is also equal to the standard deviation squared. So if you want to find the standard deviation, we can just do the square root. We can just do the square root of the variance.